Okay, welcome to the lesson on pulley systems. So in this particular question, we're going to be going over an example of a pulley system. So you have a, um, a pulley here, and you have two masses of 5.2 kilogram mass attached to the pulley and a 4.3 kilogram mass attached to the pulley. This string goes all the way around and connects to the two masses together. And the pulley is just this wheel that is free to turn as, as the masses pull on each other. And so this system is going to move downwards because the 5.2 kilogram mass is heavier than the 4.3 kilogram mass. So it's going to move, the 4.3 kilogram mass is going to move up and the 5.2 kilogram mass is going to move down. So we're going to do a few things here. We're going to draw a free body diagram for each mass. Then we're going to write an equation for net force and solve. And then we're going to solve for the acceleration of the system. And then we're going to find the tension in the cable. So let's begin. So starting with the free body diagram, the 5.2 kilogram mass is going to have a force down, pulling it down, Fg, and it's going to have a tension force pulling up. Okay, so this mass has a force Fg pulling down, and the 4.3 kilogram mass is pulling it in the opposite direction, and so there's a tension force acting upward. The 4.3 kilogram mass is going to have a tension force. We're going to call this negative T because the direction that the objects move in is going to be considered the positive direction. So in this case, Fg is considered the positive direction because this mass is going to be moving downward, and that the direction that the masses move is considered the positive direction in a pulley system. So the 4.3 kilogram mass is going to have a force Fg pulling down on it as well, and it's going to have a tension force pulling it up. Now this tension force, this Fg, is considered to be a negative force. So we can call this Fg1 and it's positive, and we can call this Fg2 and we consider this negative. And that's because it's pulling opposite the direction of motion. So remember, direction of motion is always positive. If Fg is in the direction of motion, then Fg is also positive. And then we have a tension force here pulling up, which is going to be a positive tension force because it is moving in the direction of motion. Okay, so these are the free body diagrams. You have positive tension force pulling up on the 4.3 kilogram mass and a negative gravitational force pulling down on the 4.3 kilogram mass. We can write an equation for net force. So if we summarize the forces, there's four forces acting on this mass. We have positive Fg1. We have negative tension force. We have a positive tension force, and we have a negative force of gravity. Okay, and so F net is equal to the sum of all the forces. So that's equal to Fg1 minus T plus T minus Fg2. So in this case, the tension forces cancel because they're equal and opposite. As you saw in the previous presentation on tension forces, they're equal and opposite because of Newton's third law. And so our equation just reduces to Fg1 minus Fg2. Okay, so we can calculate that. So that's equal to 5.2 times 9.8 minus 4.3 times 9.8, which equals 8.82 newtons. So that's the net force, which is essentially the force of gravity on the 5.2 kilogram mass minus the force of gravity on the 4.3 kilogram mass. Okay, next we can solve for the acceleration of the system. So acceleration, according to Newton's second law, is equal to F net divided by mass. And since the two masses are attached to a rope, they're going to accelerate together. So this mass is the total mass of both blocks added together because they are accelerating together. They're attached together, so they both have the same acceleration. So this net force is accelerating both of the masses. So the mass, we can add the mass together. So as F net divided by M1 plus M2, which equals 8.82 newtons divided by 4.3 plus 5.2. And that's equal to 0.928 meters per second squared. Okay. And that is the acceleration of both masses. Finally, when you're solving for the tension force, you have to isolate one of the masses. You can pick either the 5.2 kilogram mass or the 4.3 kilogram mass and draw a free body diagram for any one of them, and then you can solve. So I'm going to choose the 5.2 kilogram mass. So I have the force of gravity acting down. Oh, let me try this again. So I have the 5.2 kilogram mass, and then I have the force of gravity acting down and the tension force pulling up. And I'm solving for the tension force. So I'm trying to figure out what this tension force is. Now, the way that I can do this, now this tension force is going to be a negative, and this force of gravity is going to be a positive. So I use Newton's second law, F net equals ma, and F net is simply equal to Fg minus the tension force. Okay, so we've solved for the acceleration of each mass. So we know what the acceleration of this mass is. So now we can just use Newton's second law and apply it to only this mass by itself and ignore the second mass and solve for the tension force. Once we solve for the tension force on this mass, then we have the tension throughout the entire rope because it's equal everywhere. Okay, so we can rearrange and solve, so it becomes Fg minus tension equals ma, and we can plug in our values. That's 5.2 times 9.8 minus the tension force, which equals 5.2 times 0.928. That's the value we got from the previous example. And then solving, we get our tension force, which is equal to 46.1 newtons. Okay, so hopefully that makes sense, and you can try the practice problems that are attached, and that concludes the presentation.